Hello everyone, this is Jordan with Peterson Journey, and today we're going to look at a Samsung top-load washing machine. It won't turn on. My mother-in-law went to go turn on the washing machine and to do her normal laundry, and the unit wouldn't power up. No sounds, no beeps, nothing.
But I don't know what it is. Just pull that thing there. I don't know. Fiddle about with it.
The specific unit is a Samsung WA65H4200SW top-load wobble 6.5 kilogram washing machine. It was purchased at Robinson Appliance and Dumaguete, Negros Oriental, the Philippines. Let's have a look at it. So here's the unit, and basically the operator would push the power button and the unit will not come on.
You're crazy.
In this case, it's already been repaired, and I'm going backwards to show you. At this point it does work. I can plug it in and make it work, but for the purpose of this fix, I'm going to go through what I did to get there to help you and others who have the same problem. To get the panel open, you start by removing these little bumpers. These little plastic bumpers that the lid hits against to make a soft close. Should be able to get them out with your fingernails.
Fire! Fire!
So the washing machine's not on fire. We're just in the kitchen and some fish is being fried. So a number 2 Phillips will remove the screws. And once the screws are removed, then you can pry it out. You have some plastic on the front. You can just pull that down, the original protection. So this is the whole control board inside. And you remove these screws, and there's 4 screws, and then it's clipped on the back side. So you just remove it up like this. And in this case you see the fix here. I've added a couple power supplies, a 5 volt and a 12 volt. This is the original power supply that was in this spot. It takes 220 input and outputs a 3-pin, which puts out 5 volt, ground, and 12 volt. And what I found is when I tested this with a voltmeter, I was not getting any voltage when it was plugged into the wall. No output. So the rest of the board I thought would be okay. I'll try making another power supply and feeding power into this to see if everything worked. And when I did, all the lights came on, the machine worked. So now it was just, how do I get a power supply stuffed in this small spot when I don't have these resources? And they want a whole replacement board for $60 or 3,000 pesos, maybe a little less. I thought, well, it's time to try to fix this ourselves and try to save the money, since we don't have budget for it. Should also make mention that this plug right here, this is the 240 in, and that plug is right here. This plug was originally plugged into here. So once I scraped off all the stuff and was able to start looking at this board, I don't see anything really burned out other than a few hot circuits that I wasn't really sure could have been the problem, but I did find a solution with the 5 volt USB and a step-up converter from 5 volts to 12, so I got 5 and 12 like a computer supply, but in a very small area. This is just a wall charger for a phone, and this is a USB 5 volt to 12 volt converter in this little thing here that I removed the USB port and wired it in direct in this little junction here. This is the original plug that plugged in here, And so I just retrofitted it and got it to fit and wired it in, so that you can still remove it if we were able to replace the board with a factory piece. So I just want to be real specific here. This is this has like a pin right here, pin 1, in this order, pin 1, 2, and 3. And you got to get the right power to the right pin, otherwise you might screw up the board. And on the diagram here, it says that, if you can look really closely in the potting, it says that pin 1 is 12 volts. Now I already know, I've traced this back because of this coupler here, that pin 1 is a white wire, 12 volts. Green, pin number 2, is negative, ground. And the black wire, pin number 3, is 5 volts. So don't get them screwed, don't get them backwards. If in doubt, test with a tester first before you plug it in. Once we've been proven that our new power supply works for this board, we're going to start assembling again. Make sure to get even the little clips right here. There's little hook points on the back side opposite the screws. I'm wearing a headlight, I might as well use it. And then the other important part is to make sure that the places where the screws hook in, the plastic gets fully put into place so that the buttons operate. So we have a solid clunk, so it feels like it's solid. And our little hodgepodge of power supply world is stuffed in there. It's not blocking any buttons. So we've got all the screws, the 4 screws added, screwed back in, and they're kind of soft, so don't over tighten them. It's easy to strip them, and you need them to be solid because of all the pressure that you push on the buttons. So probably a good idea at this point, before installing it, to make sure that you plug it in and make sure that your power comes on. Everything seems okay. And then make sure it's snapped into place. Sometimes going backwards a little bit just before you go forwards will align the plastic so you don't make double threads. And then adding the bumpers again for the lid, covering the screws. Again. Everything's still good. So there you have it. That is how we fixed this washing machine. Rather than the whole motherboard, it was just a simple power supply. We were able to save a little money, and in the Philippines, most people are poor and they can't afford to buy 15% again on the washing machine that they paid for. And they might consider buying another washing machine that won't have electronics to avoid this, but in this case we were able to solve this problem. We may get another motherboard if we have problems with the power supply when we have a budget to do so. But I hope this is helpful to you, that you might be able to be encouraged to look at your own washing machine and consider the simple fix. Thanks for watching Peterson Journey.